Welcome everyone to another Tech 90. Today we're going to talk about MultiPRO troubleshooting. With me today I've got Jesus.
Hello, everybody.
JD.
Hello.
And myself, Greg Bruns. I think you guys have all probably seen me once or twice. So in talking about MultiPRO troubleshooting today, our schedule for it is first we're going to run a clip from a recent training covering MultiPRO piping configurations, troubleshooting techniques, and common issues. After that, we'll come back and chat with you live and answer any questions up to that point. Then we'll continue with another training and cover changing settings and using the GREE Diagnostics tool for troubleshooting MultiPRO. And finally, we'll finish up with another Q&A session. We encourage you to get into the conversation. You should be pros at this by now. As a reminder, if you have questions or comments at any time during this broadcast, use the question mark icon to the right of the screen and send them our way. We'll answer any relevant questions until we run out of time. So just quick little thing I want to say, guys. Listen, the whole broadcast here, we tried to, we just did this in a live broadcast a few weeks ago. We tried to shorten it up a little bit for you guys and get to the point. So we really want, once you get out of, using that service tool and being able to troubleshoot the MultiPRO system. So I hope you get a lot out of it. Again, we're here for you guys. So please ask questions. We'll be happy to dig into those and answer them for you. So let's get started. But first, why did we choose this topic? MultiPRO troubleshooting is a topic. The reason why I chose this as a topic is because it seems like a lot of the phone calls we get revolve around contractors getting out the field, and even if they do or do not have the service tool, it's like they don't know where to start and begin. So with or without the service tool, I mean, we do talk about the service tool a lot in this broadcast, but as you will see, if you have a wired controller, you can get to some of this information from that as well. But I do highly encourage the service tool because it, I'm not going to say it replaces your gauges, but it does to start with. In other words, just plugging up the service tool, you don't even need to hook up a set of gauges. You can drive the whole system from that service tool. You can look at all the indoors, outdoor, and everything, and at least get a plan of action of where to go next without ever hooking gauges up to the unit. And you may be able to troubleshoot and diagnose the unit, figure out what's wrong with it, fix it, and never hook a set of gauges to the unit. So anyway, without further ado, let's go ahead and run that video.
On this screen, you will see that I've got a mini split piping diagram. And the reason why I brought this up is from yesterday, is to mainly point out in a mini split system, your EEV or capillary, these you can use EEV and a capillary, or they can use just an EEV, or they can use just a capillary. But as you see here, your metering device is in the outdoor unit. That's the main point here. So we go into a multi-zone. You've got a set of refrigerant lines for each indoor unit. So one indoor unit is going to have a gas pipe, and it's also going to have a liquid pipe for each indoor coil. So when we get into MultiPRO, we're not doing that. It's a little bit different in that we are using one set of pipes out to the condenser. And so to me, it's a cleaner look to a multi-zone type of system where you have one gas pipe, one liquid pipe that comes from the outdoor machine all the way to your indoor units. So as you can see right here, these would be your service valves on the outdoor unit, your small valve and big valve. They call them the small valve and big valve because they're not really, the way we've always done unitary product or traditional heat pumps, stuff like that, that we've always called them the liquid and suction line, right?
Right, yep.
So on these, though, it depends. If you're in heating mode, the big line is going to be your discharge. Your small line is still going to be your liquid. And then in cooling mode, your small line is going to still be your liquid. Now then the large pipe becomes the gas pipe. So in a lot of piping diagrams that you will see in the MultiPRO mini split world of heat pump systems, they call them small pipe, big pipe, or they'll call them liquid and gas.
Right.
Because it could actually be hot gas or it could be low pressure gas. And then if you actually venture off and go into like commercial 3-phase equipment, a lot of those are 3-pipe, where you've got a low pressure gas, a high pressure gas, and a liquid.
Those are heat recovery, right?
Yeah, in a heat recovery system. So, you know, that's why that terminology is used that way, so it's less confusing when you're talking equipment in that world of equipment. So, and the only reason why I'm spending time talking about it is because it's not the same terminology that a lot of guys are used to that are just now getting into a system like a MultiPRO system, or even really doing a deep dive into mini split systems. So I think it's important to talk about it. So what I want to talk about here is, and I'm going to reiterate it with some equipment we have set up here, but on the MultiPRO system, it works a little bit different than the mini split system. In other words, as you can see right here, that is a shared liquid line. The metering device is on the indoor unit on both of these indoor systems, okay? Now, these indoor systems could be a cassette, it could be a ducted unit, it could be an air handler, it could be a console. We have an array of different indoor unit options. And then you have a common headered gas line that comes all the way back to the machine as well. Now, I know there's some people on here going, man, it'd be nice to have those piping diagrams. Well, you do have access to these piping diagrams. All the piping diagrams I'm going to talk about today come out of the service manual. When I ever get time, I would like to highlight this diagram and make it a little bit more user-friendly to easier to read. This is an example of a machine in cooling mode. And I brought this one up specifically for a reason. Because if you look out here, this is your outdoor coil. This being the outdoor coil, this unit running in cooling mode, and I actually took this call on a MultiPRO Ultra B revision. This is a standard, but the concept's the same. This outdoor heating EEV, so if we were in heating mode, that is my EEV for heating mode, and is going to meter my refrigerant into the outdoor coil in heating mode, because now this became my evaporator. These two coils become condensers, okay? So at that point, we are flashing refrigerant this way. But if we were in cooling mode, that EEV has got to be all the way open. So the EEVs in a MultiPRO system are from 0 to 480 steps. It's a little motor in there that drives the needle seat open and closed. When it's all the way open, we get free flow through it. If for some reason in cooling mode that EEV wasn't open, then we would be going into a pump down, because it'd be no different than if you took your service valve, your small service valve, and closed that thing up. Now we're going into a pump down, pumping all the refrigerant in the outdoor unit, and it stops between this liquid pipe right here, or liquid valve right here, backs up all the way into this coil, up to the compressor. So all of our refrigerant is sucked through this gas line back into the compressor and stored in the condenser coil. So the reason why, part of the reason why I'm bringing this up is because a lot of troubleshooting that guys call us about can be easily answered just by doing some simple inspection. This was actually, the call I'm talking about was the fault of GREE. It was not the installer's issue at all. The solenoid valve on this EEV was dangling in the unit. It wasn't even on the armature of the EEV, so there's no way the motor could actually open the EEV. So this was 100% closed and pumping me down. And once he took the side panel off of there, and I told him to look for these EEVs, he found that coil just hanging there. We put the EEV coil on that valve body and had that machine up and running with no issues. So
doing a simple inspection just would have solved that.
Right.
Yeah.
So this piping diagram, I want to talk about this some more as well. This is the Ultra, the new GMV6 MultiPRO Ultra. As you can see, and that's why I'm pointing this out. If I can get my mouse to cooperate again so you guys can follow along. Here's your outdoor coil. Here's that EEV that I was talking about again. Same thing. If that EEV is not all the way open, now you guys got an unloading valve here, but still, if this EEV is not open at full 480 steps during a cooling cycle, we're going to go into pump down because we don't have any liquid refrigerant feeding out. It'd be no different if I close this service valve. So if that EEV is not working, or if the coil is not on the valve body, just like the one I ran into, you're going to have that same exact scenario. This EEV here is strictly to help subcool the refrigerant. So this is a little confusing to look at when you look at the piping diagram. That liquid line is straight through that subcooler. This subcooler, it flashes refrigerant into the subcooler and will make that liquid colder. So when they say that's the subcooler, that's exactly what it is. It's the subcooler because in some instances, depending on the load of the machine, it may need to subcool that refrigerant some more. So I hope I make that a little bit clearer. And on the service tool,
is that just to take the load off of the compressor or the unit itself, or
it's to get your liquid temperature down so we get a better flash point at our indoor EEV.
Okay.
Okay. So again, that's going to be dependent upon other load conditions within the machine that our outdoor board is constantly looking at. All the thermistors and stuff like that, just like we talked about in the mini split yesterday. It's constantly digesting all of the data that it's getting to know what the machine needs to do. In other words, as far as what the speed of the compressor, the speed of the outdoor fans, the speed of the indoor fans, what step the EEVs are at, whether you're in heating mode or cooling mode. You know, they don't have to be wide open, right? So we'll go back to this diagram because this is going to be more, we need to understand this better once I got that service tool in my hand and I start talking about that later on in the broadcast here. It's a building system here. Let's say I got a situation with a system where I'm intermittently getting compressor error codes. Put it that way. I was trying to find the right train of thought here. But you as the technician, every time you go out there, and let's say you've got this piping diagram shows 2 indoor units. Let's say we got 4. And you never get it to duplicate the issue while you're there. Okay. But every time you go there and you reset the error code, whatever the compressor error code may be or whatever the error code was, you reset that error code and you start up the system and you bring on all 4 indoor units. And you monitor it for a half hour, an hour, or whatever, and the system's working and it's not going down on fault. And you're thinking to yourself, well, maybe it's just a, maybe it was just a fluke. And it went in, maybe it was some scenario that caused that thing to weird out and shut down. But we all know that that's probably less likely. So what I'm getting at here is that's when the service tool or the GREE controllers, we're going to talk about that more. I'm just trying to prep you guys for where we're going with all this. Each one of these coils has an inlet and an outlet temperature thermistor on that coil. When you have the service tool hooked up, not only can you see the temperature of the outlet of that coil and the inlet of that coil right after your metering device. So if you're in cooling mode, that ought to be flashing off pretty good, and we ought to have a fairly cold input to that coil, right?
Yep.
Then as it travels through, the refrigerant travels through the coil and it absorbs heat into the coil, our leaving thermistor should be significantly warmer than our inlet, right?
Oh, yeah.
That's the data that I keep telling you guys the service tool will answer for you. So if you've got 4 heads, look at the data on each coil. Look at the EEV step. Let's say that thing's open at 150 steps. And that inlet temperature sensor is basically room temperature. What does that tell you? I'm not getting any refrigerant into that coil. Could I have a bad EEV? Yeah, most likely.
Or restricted strainer.
But you could also have a restriction in the refrigerant line. You could have a restriction in your piping. You could have had where when you bent the pipe, you didn't know it, you kinked it. I don't know. I'm just giving you all scenarios. I'm not throwing the blame to anybody. But if that EV is wide open and I'm not getting that temperature differential and I'm not getting that flash gas right there entering that evaporator, then I know that indoor unit's a problem. And if I have 4 indoor units, the other 3 are working fine, I'm not going to get that compressor error code. But if I go in there and I shut this one down, shut that one down, shut the other one down, and leave that one on, now there's a good possibility I'm going to get a compressor error code because the refrigerant's trying to pump up against a block that it can't get through. I'm not getting my cool refrigerant gas back to the compressor. The machine's going, what is going on here?
Either low pressure or high pressure fault.
Possibly, or even just the amp draw on the compressor went too high because it's beating up against the head pressure.
Right.
You do have high pressure switches in it, as you can well see in this diagram, but that doesn't mean that machine's going to fault on high pressure before it faults on something else. It also depends on the type of restriction, and I've dealt with this even with standard equipment. When you have a block in refrigerant, let's say your restriction, maybe we close this service valve back and we start backing that liquid up in here. This is what I've seen even in traditional equipment. If I got a restriction, let's say I got 1 indoor coil, 1 outdoor coil, I've got a restriction. When that unit fires up, that head pressure will go, if you watch your gauge, will go way up. And then all of a sudden it starts falling back down. The reason being is because you've pushed that liquid up against that block, it can't go, it can't go, it can't go. So now it just starts stacking that liquid all the way back into our condenser coil, and the refrigerant's just kind of sitting there stagnant with nowhere to go. And since I'm not able to suck any back to actually pump it, I can't build that pressure anymore. The pressure drops.
Yep.
So right at startup, you get high head pressure. Maybe not high enough to trip a high pressure switch, but then we start backing all that liquid up into our condenser. Okay? So just because you've got a restriction, and this is where I've seen a lot of guys go wrong with that in the years that I've been troubleshooting and dealing with HVAC equipment and refrigerant flow issues, everybody always wants to think that if I've got a restriction, I'm going to have high pressure. That's not always true. You may have high pressure to start with, but once that liquid backs up within the system, it can't move anymore, head pressure drops. So, all right, moving on. Again, I just wanted to share these diagrams with you guys a little bit. This doesn't show the indoor units. This is the piping for the GMV6 Ultra in cooling mode. This is the one for heating mode. We did revamp these diagrams a little bit to put an actual reversing valve in there. It makes it a little clearer to see the flow through the reversing valve. And if I go back in my piping diagram, this is the way GREE does them. They just have this little circle up here, which to me is a little more confusing than it is when I actually change up the diagram. So, I mean, this is their diagram. All I did was, and had this put in the service manual, all we did was take out their little circle and made an actual reversing valve. We didn't change the piping at all. And the same with heating mode. Just kind of showing your whole flow through and highlighting it, making it a little easier to read. When time allows, hopefully we'll have time and we can highlight this diagram a little bit better and take this out and actually do a reversing valve picture in there. But it still gets the job done. You can still read the piping diagram to, help you with flow issues. All right, so before we get into all this, so I just wanted to go over the piping diagrams first. We'll get off the shared diagram, start talking more about the service tool and other things to be more mindful of while we're installing these units. So with that, JD, you want to talk a little bit about the piping connections on the back of a wall mount or even a cassette or a ducted unit?
Yep. So as you can see, there is flare connections here. We definitely want to use those. The factory puts them there for a reason. Also, when you're brazing the rest of the line set in a MultiPRO system, You want to flare these because you can't purge through, the EEV might be closed, plus there's strainers in there. So you just want to use the flare connections because that's why they're there. The factory put them there for a reason.
So let's talk about that a little bit more, JD, just to be a little bit more, to have a conversation about this, right?
Yeah.
First of all, I'm going to be transparent with everybody. This is not a GMV wall mount. This is a mini split wall mount, but it had the flares in it. It was easy. I didn't have a wall mount like that to share with you. Matter of fact, this is even an R32 wall mount. But anyway, what I want to point out is I've had this phone call several times. And the guys tell me they cut the flares off and they use press fit. Well, I'm not going to tell you you can't do that. I'm telling you that you're probably going to have problems because your copper piping coming up to this would be 3/8. This one would be 1/4. That is going to be 3/8 United States measurement in inches. That pipe is metric.
That's correct.
That pipe is metric. So your press fit is not going to fit that pipe properly, and you're probably not going to get the proper seal on that metric pipe.
It could leak eventually, even if it doesn't right then.
And then you could potentially have a leak. Correct. The brazing, I don't want the brazing on the back of these heads for the reasons he was talking about, but also on the GMB wall mount. If you pick that insulation back, there's a strainer here too. And if you're brazing on this head, you could possibly overheat and damage the strainer. So what I tell guys all the time, and we've preached it to the choir with mini splits, and I'm going to preach it again, the manufacturer puts flares on these. They've been doing flares well before I even got into this business. The advantage that you guys have to doing flares today compared to doing flares years ago is we now have proper torque wrenches, we have torque specifications to torque those nuts to, and you even have good quality flaring tools. You even have power flaring tools, and they even give you flare gauges to make sure that when you flared that flare, it's proper. So as long as you're using a flare gauge, cutting that pipe, reaming the pipe, flaring it properly, and torquing it to specification, you shouldn't be having issues with flares. Back to JD, back to your point about flowing nitrogen. On the GMV wall mounts, the EVs are supposed to come factory open some. Not open all the way, but I've also seen where that's not always true. What I've talked about in other MultiPRO trainings is when you're flowing nitrogen trying to braze, and let's say you're doing a MultiPRO system and you've got 4 indoor units. That's a lot of piping. And if you hook up your nitrogen at the outdoor unit and expect to flow nitrogen through all of that piping, all the way to your last wall mount, you're probably going to not have enough nitrogen there. Or you've increased the pressure on your nitrogen so much that by the time you braze that one and you start working your way back to the unit, now your pressure's too high, you're blowing your solder joint right out of your joint. So since you're going to be doing multiple pipes and multiple things, what we recommend you do is work from the wall mount or from the last point of reference backwards. So what you could do, if your refrigerant lines are coming up here, rig you up some Schrader fittings that you can put on your pipes there, flow the nitrogen from here, and do your braze at the other end. You're going to be leaking here a little bit, but as long as you don't need a lot of nitrogen in the pipe, you just need enough nitrogen in there to displace the oxygen.
Yep.
That's it. So even if you're leaking a little bit, if your solder joint to a manifold or a wall or a Y branch is only 15 feet away and you got your nitrogen flowing right there and you just go over to that 15 feet away and braze it, then you can take that and move it to the next head. And so every job is different. I can't talk specific to every job, but what I'm saying is use your mind a little bit and where's the best place for me to flow my nitrogen from to make it convenient for me to be able to make my joint, know I have nitrogen in that pipe, and then move on down the line and work your way back towards that condenser. That's what I'm trying to get at here.
Right.
If you just put a little, like I said, again, I can't speak for every job for you guys. You guys are smart guys out there doing your refrigerant piping and everything. All I'm trying to do is give you helpful tips. And like I said, you got to use your own experience at each job, but it's real easy to get complacent in what we've always done before,
Right.
and try to do it the same way, where it may not be the best way for you to do it. That's my point, okay? But please, don't cut the flares off. And then, I guess the other thing I could talk about is let's say for whatever reason, and we don't have a lot of leak problems with our units and stuff, but let's say this wall mount got a leak in it, and I need to replace it, and it's under warranty, and we end up replacing the whole head instead of just the coil. Well, at that point, it's going to be a lot easier just to undo 2 flares,
Way easier.
unhang that unit, hook up to reusing your flare nuts and everything, and torque back to a new head, and you're good to go.
Yep.
If you brazed all that, now you got to drag a torch and everything else in there, or if you got press fit, now you're cutting them off to do a whole new press fit fitting when you could have just undone the flares and flared a new one on and been done with it. So, all right, I think we covered that to a pretty good extent, don't you think?
Yep, I do.
All right, so let's now talk about the service tool. So the first thing I want to point out here, you want to grab that box? This is a pretty horrible looking box, but this is the box that the MultiPRO Service Tool comes in. It does come with the instructions on how to use the service tool, just so you know. The service tool, this is it. I've actually got it popped apart. I've got this one hooked up because this is the one we're going to be using in today's training class. But what I want to point out here is I'm using a portable power source with a USB. You can use a portable battery. It's plugged into the wall. I could have probably used my battery. I don't know what I was thinking.
Yeah.
Whatever. I don't always think things through either, guys. So I'm human. Anyway, but this is the tool we're going to be talking about. It's that same tool. I just wanted to point out when we switch up, I'm not switching tools on you. But, so here's the deal. In the box, you're going to get this cable. This cable has these little gray keepers on here. You want to grab a screwdriver,
Yep.
pocket screwdriver?
The release tabs.
Yep.
Where is
In the
one?
drawer over there. Should go in the toolbox. Grab a pocket screwdriver real quick. Thank you, sir. All right. So when you get this tool, the first thing I'm going to tell you to do is get your little pocket screwdriver on these little gray tabs on the side. It's not hard to do. Pop them off. Don't put them in the box. Put them in the trash can. You don't want that on there.
Because that way we can't plug it in, right?
Well, you can. It's getting it unplugged.
Right.
Is the trick. So then when you go to plug it into the service tool that's all together, when you plug this in, I'm being careful with it because I got it, I'll take it apart. It'll clip in there, but what I've found, if you have that plugged in, I need to do it on this one because it's not all taken apart. Then you can unplug it and plug it back up. If you do it and leave that keeper in there, it keeps you from squeezing that tab to be able to release it. So you really fight getting it to unplug. That's my whole point there. So make sure you're getting rid of them gray keepers. Now, the reason I have this taken apart is because it's really easy to pop apart. I just used like a pocket screwdriver. I popped the thing apart. It's a great service tool. The one thing that GREE didn't do a very good job of is right here. This is that USB power supply coming into it. The only thing that is wrong here is the only thing that's holding that in there is the 4 solder joints for the 4 wires. So it breaks really easy. So this one hasn't been done yet, but my tool over there, I pop it apart and just get a hot glue gun and put a little bead of hot glue across the back here. Don't block your port, but just a little bit of hot glue over it, let that dry, and then you can pop the tool back together. Like I said, it literally comes apart super easy and pops right back together. Now that port is glued, it's solid. Plug it and unplug it, and you're not going to break the service tool.
We've tried and tested that.
I broke 2. I broke 2 literally just having it sitting on my desk at home, and I had it hooked up to a portable battery supply, and I bumped it off the thing, and just the weight of the battery ripped it right out of the socket.
Right.
So, or I think it was the other way around. I think I knocked the battery off, and the weight of the battery with the tool sitting there ripped the socket right out. So that's one thing. The other thing is this. So most of the units on MultiPRO, whether it be a cassette, a wall mount, a ducted unit, they have the 4-pin Molex plug on the circuit board in the machine that you can plug up to make the service tool work.
That's on the indoor head, right?
On the indoor unit. And sometimes there's more than one 4-pin plug. Don't worry about it. You don't need to know the specific number of which one you plug into. The one thing I can tell you is if you plug into the wrong port, it won't hurt the tool, it won't hurt the machine.
It's just not going to give you the readings.
Just look at the 4-pin plugs, plug it into one. If it works, so you got the right one. If it don't, you got the wrong one. Trust me when I tell you, it won't hurt the tool. But some of the machines, like the wall mounts especially, that plug-in is all the way in the back of that circuit board. So getting to it is not the most friendly way to be able to hook up your service tool.
Right.
The outdoor machines, the standard MultiPRO and the new Ultra do have the 4-pin Molex plug on the board for you to be able to plug up the service tool. The MultiPRO Ultra B revision did not. On the outdoor unit, there is no port on that board for you to hook the tool up to. So you can do this a number of different ways. I found these on Amazon. They are 4mm 4-pin connector. I think I paid $8 for 20 of them. And it's just a female receptacle plug. It will plug right up to here. The colors don't match, but don't care about that. Red and black on GREE's plug, red and black of this plug is D1 and D2. Brown and orange is power supply.
So the 2 center ones is what we want to use.
2 center ones. So if I put this little adapter on here, again, it's not color matched.
The 2 center wires is all you want to use.
I went from red to black to red and white. Then I can take that red and white wire and hook it to D1 and D2 anywhere in the system. As long as I have the portable power supply hooked up to the service tool, the portable power supply will power the tool. This will give you your communication into it. I can hook up anywhere on the system. So, or let's say you don't want to buy those on Amazon because they don't come with the tool. You could do what I initially did, and I just took one of these cables and I cut it off, and then I just set it up to where I only use the red and black wire. But it also made it where I could put the red and black wire and the orange and brown back, hook the plug back together, so I could actually use the whole plug if I wanted to. But then I found these adapters, and that just made life easier. Okay, so just an FYI, there's more than one way to skin a cat, right? So, but if you are going to use the portable power supply, I do highly recommend that we are, securing that port, because just a few times plugging and unplugging, you're going to break it. And then if you plug and unplug after it's glued, you'll see, oh wow, that's not more solid in there.
Right,
So,
major difference.
all right, so now I want to redirect your attention over here to these couple units that I have sitting out here. On this coil, just like the wall mounts, the ducted, the cassettes, all of them, as I said earlier in the piping diagrams, you have an inlet and outlet temperature sensor. So right here is the inlet temperature sensor coming from our refrigerant feed in. And then here is the outlet right on your gas pipe coming out. And then so I'm not have to be bent over anymore. I'm going to come over to this other coil that's doing the same thing. This is our new dual fuel coil. Make sure Nick's followed along with me here. And I got the whole control panel taken off here just so for show and tell. But here's our inlet pipe temperature sensor. Here's my outlet pipe temperature sensor. So they're a lot easier, a lot closer together on this particular coil. The one thing that I want to point out to you, make sure you realize, is on the service tool, they are marked as inlet and outlet pipe temperature sensors. If you're in heating mode, that's backwards. Because in the tool, it still says inlet and outlet. But remember, you're flow reversed. So now we're flowing hot gas into here. So now your outlet temperature sensor becomes your inlet temperature sensor. And your inlet becomes your outlet because your refrigerant flowing the other way. So you got to keep that in mind when you're in heating mode. Inlet and outlet are reversed. In cooling mode, that is your inlet, that's your outlet. Heating mode, that is your outlet, or your inlet, and that is your outlet.
All right, guys, just remember, hit that question button if you have any questions so far. Otherwise, we'll just continue on.
Welcome back, everyone. Hope you enjoyed that so far. Hope you're getting a lot out of this. With that, let's go ahead and jump right into the questions. First question came from Alex. What is the best way to check when the board is bad? What voltages are supposed to have at the outdoor terminal? Is there a book that tells us what voltages we should have? Jesus, let me give you a chance to stab at answering that question.
I think that's a really good question, and I think that applies for all our products. I'm sure JD can attest to that question, especially on the mini split side. We're suspecting a bad compressor. What are we going to check? What other voltages? What are we checking for? And I would like to just add to that one is, we can check out the compressor and just do a quick ohm reading. And, what should we get across the terminals is pretty much equal resistance on all of them. And that's just like a quick reference that you could do just to say, hey, this is probably not going to be the issue. I need to keep looking further. And JD, if you want to add into that or just add anything that you.
Yeah. Also, check the grounding to the terminals as well when you're checking the ohms. Like you said, just be sure to check the ground, make sure it's not grounded. But other than that, testing the board, we're actually going to get into here in a little bit. And then in the next clip. So that'll answer a lot of questions going on that too.
Yeah, and we also talk about in that when you're ohming out a compressor, you got to be very careful because if you're reading a mega ohm reading to ground, that doesn't necessarily indicate a grounded compressor. You need to make sure that you're at K ohms.
Yeah, good point.
Or hundreds of an ohm or something like that to ground it. Mega ohms is not, because effectively what I'm trying to say is, the ohm reading that you can get from a compressor terminal to ground can be in mega ohms picked up because of the oil sitting in the compressor allows it to conduct through to the case. So, and like I said, that's what I said. So if you got mega ohms, that doesn't necessarily mean you got a bad compressor.
And a lot of meters auto range too, so you got to be careful of that. Sometimes you'll just have it on ohms and think it's reading ohms, but it'll actually say a little M at the top, and it's reading mega ohms. A lot of people mistake that.
And that's something I like to address too is, and I'm not speaking to everybody out there. Most of you, hopefully you guys are not doing this, but I can tell you there's been a whole bunch of times that I've had to, when I was on the phone with a contractor troubleshooting a unit, that I had to Google their meter and pull up the manual.
Yep.
To know what the tolerances of their meter really are and how their meter functions. I guess the thing I'm trying to say is, guys, if you buy the tool, read the manual, make sure you know how to use the tool, make sure you know all the possible set tests you can do with the tool. Make sure you know the tolerances of the tool. Don't throw the manual away because the meter doesn't always, have enough room on the meter itself to tell you what the ranges and everything are. So, keep your service manuals or your instruction manuals that come with your service tools for reference when you need them. I can't stress that enough. It amazes me how many guys don't know the capability of their own tool.
Right.
So,
or even when they're trying to ohm out the sensors and it's a K ohm reading and their meter only goes to a certain K ohm and they're thinking the sensors are bad, and really it's just their meter doesn't go that high. So good point.
I actually had that, but years ago I was teaching a training class and I had a young lad come up to me and he had this compressor they were ohming out in the class, and it had a specific reading. It was a very high ohm reading, and it really indicated a winding short. Well, he come over and he says, Mr. Brunson, he goes, I can't seem to get that reading off that compressor like everybody else can. And I'm like, huh, okay. And then there was another person that I was working with. I was like, can I borrow your meter? And I go over and I test it, and it showed it just like I said. I said, well, I don't know what your problem is. I'm not having any problems. I went back. This went on 3 times. And finally, the student come up to me. He goes, Mr. Brunson, what am I missing? I said, did I ever use your meter? He goes,
Right.
what do you mean? I go, well, look at your meter. It says it right on the front face of it. 1,000 K ohms max. It wasn't capable of reading the ohm readings on that compressor because what we were reading was well over 1,000 ohms. So it's the same as what you're talking about there, JD. You got to understand what the tool's capable of doing. So I'm not trying to beat anybody up for that, but I'm telling you, I've had that phone call probably a couple hundred times where I've had to Google their meter and pull up the manual and tell them how to use their tool. And I shouldn't have to tell you guys how to use your own tool. So just take the time, learn your tools, Moving on, other questions. This one came from Joe. Joe asked, he says, so you do not recommend using press fitting at all on installs? That's not exactly what I said. I don't recommend you cut off flare fittings of GREE's equipment in using a press fit. They do make flare to press fit adapters. So if you really want to do press fit at that indoor head, buy the adapter that's flared to your press fit, do your press fit on that fitting. Same with the outdoor unit. I actually had a guy fall on a GMV6 Ultra. The GMV6 Ultra, if you look at the quick start guide that is on our website, it shows a picture of the dog legs that are shipped with those units. The 3, 4, and 5 ton units all come with those dog legs. You can bring the refrigerant lines out the front. You can bring them out the right side. You can bring them out the back. The service valves are up inside the unit. When you go to hook it up, even though if you look at the basic layout rules on our quick reference guide, 3 ton and 4 ton requires 5/8, 3/8 piping to it going to your header or to your first Y branch. The service valves in that unit are 3/4. That dog leg will accept 3/4 or 5/8 braze. The 5/8 pipe will go right into the dog leg. The 3/4, obviously it's 3/4 pipe already. You can braze to that as well. The particular individual that called said he threw them away. I said, okay. And he says, because I'm not brazing, I'm doing everything press fit. I'm like, okay. Don't you have a 3/4 flare to press fit adapter? He says, yeah. I said, well, there you go. If you ran your piping all the way up to the service valve, just use your adapter right there. And he goes, oh, okay, I guess I can do that. So it was no big deal. But I'm telling you guys, I want you guys to be aware of that too, because even though the valve is 3/4 on the GMV6 MultiPRO Ultra, those units, they are 3/8, 3/4 service valves, but 3 and 4 ton is 5/8 to the condenser from the Y branch or header. 5 ton is 3/4. So anyway, the dog legs are pre-bent, so they're not that hard to finagle. The other thing I really like about the new GMV6 Ultra and I'm sure they'll be implementing it into the standards as we move along. But they also come up with a real nice rubber boot that goes around the refrigerant lines that fits that knockout for the refrigerant pipes. And you just take a couple zip ties so you get a real nice seal around your refrigerant lines through that hole in the panel. I really like that scenario and setup with the new GMV6 Ultra. I think you guys like that as well. So anyway, moving on from there, what is the tool part number? We're going to throw that up for you. It's actually in the end of the broadcast. We show a slide of the service tool part numbers, not only for the MultiPRO, but also for the mini splits. But there you go. There's the part number. It's a CE4224FC.
Hey, Greg, I just wanted to add a couple of things before we move on. Talking about the GMV6, I just want to point out the GMV6 just did receive an update in the past couple months, and it has a plethora of information there regarding these systems. And we were talking about earlier,
you're talking about the service manual.
Yes, the service manual. Okay. So a lot of that information that's in there, it's a lot of great troubleshooting information with exact values of what you should be seeing whenever you test out the board, the compressor, things like that. So go ahead and go and check that out at GREEcomfort.com. It's under GMV6 Ultra Heat Service Manual.
Yeah, so the other thing that I like to tell you there is GREE does a great job of not really duplicating codes all that much. In other words, if you're working on a standard MultiPRO, but you pull up the manual for Ultra, those error codes would be the same on both those machines. What you have to be careful about is mini split versus MultiPRO. Some of those codes do duplicate, and they mean totally different things. An L3 error code on mini split is outdoor fan motor failure. L3 error code, I believe, on GMV is condensate drain.
Yep.
So be careful. Make sure you're referencing proper manuals when you're looking up error codes. The other thing that I will tell you is on our website, we have an error code troubleshooting tool. Do not use that for MultiPRO. That is specifically for mini splits. If you use that for MultiPRO, it's probably going to steer you in the wrong direction. So rather you not use that at all. One of the examples I have for that is E6 communication error code. MultiPRO doesn't have an E6 communication error code. It's CO for communication error code. So anyway, but like I said, if you pull up the Ultra manual that Jesus was talking about, it's quick reference a lot through there, a lot faster. So if you go to the manual, you open up the PDF, you'll see in the table of contents, like the error codes list, you click on that, it'll take you right to that list and gives you all of the error codes. You don't have to sit there and scroll through the manual or anything like that. So it is a lot better. And the piping diagrams, refrigerant piping diagrams are in there along with the wiring diagrams. So with that, again, guys, the video is from a previous broadcast. Us coming to you guys answering questions is live. So we encourage the questions. So keep them coming at us and we'll do our best to answer them. So with that, let's roll with the next video segment.
So first of all, I want to point out, I don't have the tool plugged up to the machine at the moment. I just wanted you guys to be able to see it. Okay, first thing you want to do when you get this tool is because it's going to become set up as metric. You want to change this tool to standard or British system so that you get everything in Fahrenheit and instead of Celsius, and it's going to make things a lot easier. So let me go back one here. Hold on. Project setting is where you're going to go. You're going to go to page 2. You're going to go to controller setting. You're going to go to unit of measure. And as you can see, if I put that on metric, is where it comes. I've already changed my tool to British. And then all I do is hit back, main page. So now everything I'm going to read on this machine data-wise is going to be in Fahrenheit. So it's going to make it real easy. That's one advantage that this tool has over the mini split tool, because the mini split tool is all
We have to translate.
Celsius, and you got to translate it all. This tool, you don't have to do that. With this service tool, you can actually force it into startup, or for whatever reason, GREE calls it debug. I hate that terminology because it sounds like you're fixing the unit, and it's really not fixing anything. It's just the startup process. You don't have to use that. We have talked about that in videos before. We got quite a bunch of videos of how you force these machines into commissioning. When you see the AO on the screen, that just means the unit needs to be put through startup. Once it finishes startup, excuse me, in heating mode or cooling mode, you're done. You're ready to turn the machine on. So you can actually do it from the service tool. You can also get system status where it gives you error codes and stuff like that. But what I normally use on this tool more than anything is unit control, and then also observation of the unit to determine what's going wrong with the unit.
So we can check all the sensors, all the EEV steps.
If I go to unit control, I can control the entire system from this tool. So now you got to choose what you're going to drive. So you go to unit control, you go indoor unit. As you can see on this system, there's 2 indoor units. I can do select all, or I can just do 1. So you can see right now I'd only be driving unit number 2. I'm not driving 3.
Right.
But if I do select all again, now you'll see it highlighted both. Now I hit OK. So now I know whatever I do here is sending that command to both units. Then I can put them in heat mode or cool mode or dry mode or fan mode, whatever mode I want to put them in. And I can also set my fan speed. When you look at this, the fan speed, when the arrows are all like that, that is auto fan speed. If I hit it a few times here, that's going to be low. That's going to be like 1 step higher.
Medium, low.
1 step higher. 1 step higher. 1 step higher. And then auto. So we'll go back to auto.
And do we recommend having it on auto all the time?
I do, and I'm going to get into that in just a minute.
Okay.
So then, again, I'm doing all this. I'm not even talking to the unit yet. I just wanted to show you the control. So even once you get the control, if you've never had one before you even get to the job, plug it up to a USB cord and play with the tool. Go ahead and set it up for British. Go ahead and get it ready to go. Get familiar with, remembering how you drive all the systems on and stuff like that. Okay, so we'll wait a minute and let it get started up. Meanwhile, I'm going to talk about something, okay? I constantly get asked the question, are these units variable speed? Are the air handlers variable speed? Are the ducted units variable speed? The answer to that question is yes, they are variable speed when they're in auto mode. The key to that, though, is it's not the variable speed that a lot of guys are used to. What I mean by that is variable speed means, and a lot of guys look at it this, with you in unitary product, in other words, standard systems we've always dealt with, when you put that thing in cooling mode, or you do profile setup on that furnace or that air handler or whatever, on variable speed, you're typically setting it to a specific CFM per ton, right? Mm-hmm. In other words, you're going to go in there, you're going to go to the dip switch settings, you're going to say, I want this thing to deliver 400 CFM per ton. And what it does is it was going to try to ramp and achieve that 400 CFM per ton. And let's say you got a 3-ton. So it's going to try to achieve 1200 CFM regardless of the static pressure on the machine. So if you've got high static, that blower motor is going to ramp up even harder, trying to overcome the static to keep delivering that 1200 CFM. Whether the motor can actually do it or not is a different story, depending on the ductwork and stuff like that. That's the way variable speed MultiPRO works, or in any inverter-driven unit. The way variable speed works on these is it will adjust the blower speed according to the inlet and outlet temperature sensors and the EEV step and the load that's on the machine. So if you have very little load, you're going to have a lower blower speed. If you have a very high load, then you're going to have a higher blower speed.
Right.
So you don't so I just want people to understand what variable speed really means in inverter-driven equipment, especially MultiPRO. Okay?
Yep.
All right, so now we're running. All right, so now I can go back. I can go to indoor unit status. I can select both of them, and you can see right now, man, these things are cranked up because I've got such a high demand on it. Indoor number 2 has got the EEV set at 351 steps. Indoor unit number 3 has got it at 366 steps. Now I can hit that number 2 button, go specifically to that unit. It's telling me that's a 2-ton indoor unit. It's project number 2. The state of running is on. The fan mode is stop. Because the way these machines work, the fan's not coming on until the coil's warm. Now it's starting to come on. I think this is the 2-ton, but I ain't going to swear to it because I got them both coming on anyway. Temperature settings, 82. Indoor ambient is 72. We got a 10-degree demand. Inlet temperature's 91. We're running in heat mode. So now that's actually the outlet. Our inlet is 104. So if you give it a little bit of time, that differential is going to go up. That's what I want to see.
Right.
I should be seeing. This unit number 2 is also the master indoor unit. That also tells us that. The V steps 367. E-heater's off because this one don't have an E-heater anyway. Left, right. So
That's our louvers.
freeze protection, all of that. Cool. Now let me go back. We can also look at our outdoor unit status. Keep in mind these service tools, this is the same service tool. If I went and hooked up to a 3-phase heat recovery unit, I can view up to 66 indoor units with the same service tool. That's why it's saying compressor number 1 operating frequency 0. We obviously know the compressor is running, so give me just a second, we'll get there. Rated capacity 30,000 BTUs. Outdoor ambient temperature 68 degrees. Fan motors are running at 30 hertz. Compressors at 34 hertz. We're not even begun to really ramp this unit yet.
That's pretty low.
Well, and if you think about it, again, that's part of the whole idea behind this training is hopefully you guys can help start digesting what I'm trying to tell you here. You got to understand what the machine's trying to do, where the refrigerant's flowing, where's my metering devices. If I understand how it's supposed to work, then I can start diving into why it's not working. That's my whole thing here. Well, to me, I got a 10-degree demand, right? My fan motors are only at 13 hertz. My compressor's only at 34 hertz. Why? Well, I'll tell you why. Because the outdoor temperature is 68 degrees.
Right.
If the outdoor temperature was 20 degrees, you would bet that that fan speeds would be higher. The compressor speed would be higher because I'm having a harder time absorbing heat into the outdoor coil in heat mode.
Got to ramp up.
Because I've got a colder outdoor temperature. Okay? That's why I said you got to start thinking like the machine's thinking so you can understand what the thing is doing. It gives me my high pressure and my low pressure both in pressure and in temperature.
Yeah.
So I'm running 400 or 398 psi of head pressure and 173 pound back pressure. Makes sense to me when it's 68 degree ambient that outdoor coil's in, right? You wouldn't be seeing suction pressure that high if you were in a much colder environment. You probably would still see that head pressure because the thing's trying to build that head pressure so we get that discharge temperature, so we get to release that heat. These things do a great job of giving you a nice warm heat off the coil. and we'll go back and revisit that in just a second. So there's a lot of useful information here. It's also giving me the compressor discharge temperatures, 127 degrees. We talked about that yesterday. All the way up to around 150 degree discharge temperature, or maybe even just a touch higher, I'm not alarmed by that. But if I start seeing that discharge temperature at 175 plus, I'm beginning to wonder why I'm not getting enough refrigerant back to my compressor. If I start seeing it over 200, I know I got a problem. I'm not getting my refrigerant back to that compressor, or I am overheating because of lack of refrigerant. Again, that goes back to what I talked about yesterday with the mini split. I may have enough refrigerant in this machine. If I got 4 indoor units, I may have enough refrigerant to satisfy one, but when I bring in all 4, now I don't have enough refrigerant anymore, and that's why it can't keep up. And it's because with all 4, I'm low on gas. So if I start shutting units down and all of a sudden my temperature rise goes up on that one and my temperature split on my indoor unit, if I go back to indoor unit status, go to number 2, let's see what kind of differential. 124 degree inlet, 90 degree outlet. That's a 25 degree, or no, 35 degree, right?
Yeah, 34.
My math's horrible. 35 degree rise, you know, differential across that. We're heating. We're absolutely heating. That's what I want to see. So now, and I always say, to me, it's a lot easier for refrigerant diagnostics in cooling mode. And these machines will run in cooling mode all the way down to 0 with no problems. So when in doubt, check it out. Run it in cooling mode. That may make the refrigerant diagnostics for you easier doing it in cooling mode.
Good point.
So anyway, that's a good differential. So let's go to unit number 3. And let's take a look at that one. 18 degree differential. Not as high, but still decent. I wouldn't be complaining about that. EV step 339. Remember, this is going to be fairly open anyway. Because when I said, well, that EV is really calling. And I think about when you step back and actually think about it for a minute, now wait a minute, I'm in heating mode. I want to open it up. I want to get good flow through there because that's my discharge line, right?
Yep. Oh, yeah.
I'm trying to flow. I'm not flowing through my discharge line. I'm flowing in through my discharge line, which would be my outlet of the coil. But I need that free flow of liquid to go out the other side. I really don't want to be metering refrigerant into my liquid line going back to my outdoor unit from my indoor unit. So that EEV should be wide open or fairly wide open in heating mode, right? So maybe we go to unit control and we're going to go and shut this down. Oh, wait a minute. Hold on. Before we do that, remember, I got to hit the check mark to command it. So while you hold that up there, the other thing I want to talk about is, depending on the controller that you have, this is the XK46. The manuals, there is a way to get into it. I'm going to just do it on the XE70 because it's easier and faster. But you can get into it this one too. But this one's super simple, and the XE7C is super simple as well. But I can go right here, and then I can go to View, Enter, and I can go to Project View, go down, come on, up, Parameter View. That's what I want to see. Sorry. Gotta play sometimes. Inlet, outlet temperatures. So if you've got a wired controller, you can actually go see this information on the wired controller as well. But if you've got all cassettes and all wall mounts and you don't add the optional wired controller, now you have no diagnostic information because you can't do this with the remote. This gives you some really good information. And it'll also go through here and it will give me the EEV step. EED Indoor unit EXV status, 16. So that one's a little trickier too, so let me point that out. We've seen in here we're way up in the 300s. My math is horrible, okay? I only have a 2-digit display there. I can't give you the full step. So it is 1 to 20. Meaning, you got to bust out the calculator. 16 times 24 equals 384 steps. That's what that controller is telling you. It don't tell you the actual step like this one will tell you. Hold on. I'm trying to go through it too fast instead of. All right, so I'm going to that status view of indoor unit. This one's at 414. Unit number 3 is at 325. So
That's right where
it's
that
close.
was. Yeah.
It's close. And it doesn't need to be exact. What I'm telling you guys is for troubleshooting purposes, you don't need to be that perfect. All we want to know is that VEV wide open? Is it not wide open? So what we're going to do, and give JD a break from holding this thing up here, we're going to shut it down. All I'm trying to tell you guys is the service tool gives you what you need to know to figure out what's going on with that machine. You don't have to hook gauges up to it. You don't have to hook up, you don't have to do a whole bunch of thermistor readings and stuff like that. You can go to the indoor unit status and look at the indoor ambient, and if it says it's 68 degrees, is it 68 degrees? If it's not 68 degrees, if it's 85 degrees in there, then we need to dig into that indoor ambient thermistor, right?
Right. Oh yeah. And think how much time this can save you. You know, these jobs can be real big with tons of several indoor units. You don't have to go to every indoor unit to get these readings. You can just hook up to any unit and get every single reading you need.
Now we say any unit, any MultiPRO unit.
Correct.
Just be careful here.
Any MultiPRO unit, yes.
When you replace a board on any MultiPRO system, you have to make sure the capacity dip switches are set. These capacity dip switches are what defines the rated capacity of the outdoor unit. So when you change the board, the way the service manual reads is these are not adjustable. Well, I'm here to tell you they are adjustable. And these are what the settings are for MultiPRO Standard. These are the ones for Ultra. You guys really don't need to have a copy of this. We did put this in the Ultra manual. I don't think this is in the Standard manual, but if you ever have a question about this, you can call us and ask us. We'll happily answer it. My point being, though, is if you have to replace the main board in any one of these MultiPRO machines, the SA1 dip switches are covered with hot glue because the factory doesn't want you adjusting them, okay? But when you replace the board replacement is going to be more like a generic board, so you have to set those capacity dip switches the same as the original board. So it's just hot glue over it. All you got to do is take the hot glue and peel it off of there. It's not hard to get off. And whatever these capacity dip switches are set for on the old board, make sure you set the new board the same way. Also look very closely and make sure if there's any jumper caps. These are some examples of jumper caps. You see that jumper cap, your new board is not going to come with that. You have to take the jumper cap out of the old board and put it in a new board. Otherwise, you're going to start that machine up and immediately have an error code. Function settings of it. Again, this is covered in the service manual. Just kind of a refresher for you guys. You can go through these function codes. Function codes are like A2s, refrigerant recycle. That's the same as pump down. It's not going to magically close the liquid line service valve for you. You still have to manually close that liquid line service valve, but you can put it in refrigerant recycle. That will pump all the refrigerant into the outdoor machine.
Doesn't it open all the EEVs?
Mm-hmm. Or it'll open up the EVs and it's going to pump all the refrigerant into the outdoor unit. It does it like a cooling mode pump down.
Right.
Okay. This A6 cooling heating of the entire system, this is a code that you could actually force this machine, if you wanted to only run in cooling or only run in heating. I don't know why you guys would want to do that. A7 is outdoor silence mode. This function is set for different silence modes based on the user's needs. I would highly refrain from using that. Because if you're setting a silence mode, what you're doing is limiting the capacity of that unit so that it's not as loud.
Right.
Right?
So it won't ramp up.
So save that for, I'll do this if I have to kind of thing. The main ones I want to point out is this after sales vacuum pump mode. What they mean by after sales vacuum pump mode is, okay, I've got a machine that's got a leak in the system and I've got to correct that leak. I have no idea how much refrigerant's in the system. I need to pull all the refrigerant out of the system. And then I need to fix that leak, and then I need to evacuate that system and put that system back into operation. When I do that, I have to put that machine in vacuum mode, because that's going to open up the EV in the outdoor unit, it's going to open up the solenoids, it's going to open up all your indoor EVs, leave the machine powered, and leave it stay in an A8 mode. The entire time you're recovering all the refrigerant out, and the entire time you're doing a triple evacuation before you put that unit back in service. Even when you put the charge back in it, leave it in vacuum mode so the refrigerant will flow in there nicely for you and you can weigh your charge back into the machine. Once you're done with all that, then take it out of vacuum mode and you can run the machine again. Forced defrosting. You can drive this from that service tool. You can do a forced defrost. You can also do it from the red buttons out here as well. You can drive this into forced defrost. The service manual does cover this. We just posted the new GMV6 service manual for Ultra. The functionality to it, I just want to make sure you guys understand this. The standard MultiPRO and the new Ultra, the GMV6 Ultra, are both 4 red buttons. How you get into these function codes is exactly the same on both machines. So if you can't remember or you need to look it up, pull up the GMV6 Ultra Service Manual. It'll tell you exactly what buttons to push to be able to get into these functions and set them up. So that's your quickest reference material. Indoor unit engineering serial number offset. That's like the project numbers. As you've seen with that service tool, we had project number 2 and 3 on this unit we were using in the lab here. You can actually go into these red button push and readdress the indoor units. That's what that does. So it'll reset the project numbers so you don't have a project number conflict or an engineering serial number offset, so we don't have a conflict. This really only comes into play when you have multiple outdoor condensers and you're trying to do some sort of central control or cool automation. That's the only time that plays a role. C9 is fan emergency setting, so if you have a fan motor fail, you can go in there and it'll ignore the failed fan motor. So the machine will limp along on one fan motor until you get back with the replacement fan motor. That's what C9's for.
That's real cool.
I thought so.
Yeah.
Not going to do a deep dive. I just want to let you guys know this is in the service manual. It gives you step-by-step instructions of how you do a diode test on the board on the new Ultra. This is a liquid-cooled inverter that's in the new 3-ton, 4-ton, and 5-ton GMV6 MultiPRO Ultra. And it also gives you the test for not only the fan, but also the compressor drive part of that board. It's pretty simple. You just got to follow the manual. I've done the test myself. So I have one of them boards sitting on my desk in my office at home, and I went through every one of these tests and made sure it played out exactly the way it says, and it's on point. So that works very well. This is either standard or I can't remember which this picture came out of, whether it came out of a standard or if it came out of the Beaver Vision Ultra. But this is how you do a drive board test on those machines. The test is the same. You're still doing it from P and N. If you look right here, there's P and N. And here's your U, V, and W. And it's the same thing here. If you look at this board closely, you come over to the discharge points. It's right up in here is where you measure the DC bus. The DC bus is P and N, or discharge points. Sometimes those are what they're called.
Right.
So it's a pretty simple test to do. I'm going to demonstrate it to you on another board here. And then also, when it comes into individual testing of components, open them out, the compressor. I shared this with you here. This is out of the new GMV6 Ultra service manual. They're giving you specific resistances between U and V, V and W, W and U. Don't take that to the bank, guys, because it depends on the meter you're using and whether you're doing it through the wires or you're doing it right at the compressor, the strength of your batteries. What I really care about, I'm not worried about whether or not you get 0.197 plus or minus 7%. What I'm worried about, this is a three-phase motor. When I measure the resistance from that terminal to that terminal, and then from that terminal to that terminal, and then from that terminal to that terminal, no matter how I do this, I should have equal resistance. Typically, it's around 2 ohms. Within 1/10 of an ohm. That's the way I've always done it. So if I measure across these and I get 2, 2, 2.1, I'm done. The compressor's fine. Measuring the ground. Be very careful when you're measuring resistance from a compressor terminal to ground. And I always use just a copper pipe coming out of the compressor. That's an excellent ground source. Make sure that meter's not reading in mega. And a lot of meters, even when you have it on ohms, if you'll see, look at the meter, it'll give you a reading, but then it'll also have that M there. It's telling you it's reading mega. If you're reading mega ohms, that compressor's not grounded. If you got a grounded compressor, you're going to read resistance to ground in K ohms. Like 1,000 ohms. That means you got a grounded compressor.
Right.
When it comes to testing EEV coils, this is one of the best diagrams I've ever seen for the EEVs. Orange to gray, you're going to be around 46 ohms. Gray to yellow, you're going to be around 46 ohms. If I go from gray to red, I'm going to get roughly 46 ohms. And so on. Gray, again, if you follow it down here, gray to black, 46 ohms. Excuse me. If you don't have this diagram with you, you don't have to have it. You can actually simply take the Molex plug for that EEV, put your meter lead on the far end of the plug, and then move daisy chain through the rest. So if I leave my black lead on orange and I go to gray, I'm going to read 46 ohms. If I go orange to yellow, I'm going to read roughly double that, right? Because I'm reading 2 windings.
Yep.
Then if I go, still leave my black probe on orange and I go to red, I'm still going to read 2 windings. So what I'm telling you is, what's 46 times 2, man?
92.
My math is horrible.
92.
So what I'm telling you is, if you go across this, starting with your black probe on 1, you're either going to read around 46 or around 90 ohms, no matter how you go through it. As long as I go from orange to gray, and then orange to yellow, orange to red, orange to black, and I only read somewhere around 46 or 92, then I'm going to move my black probe to gray, and I'm going to daisy chain through the rest that I have again. Then I'm going to move my probe to yellow, and I'm going to daisy chain through the rest again. And then I'm going to move my probe to red, and I'm going to do it to black. Now I've tested every possible way I could test it. And as long as my reading is somewhere around 46 to 96 ohms, or 92 ohms, I'm good.
Right.
That coil is not bad. The other thing you want to do is make sure, and this don't happen very often, but we have seen it, is each wire to ground. You should have no resistance. If you got resistance to ground, take that power head right there off of that valve body. You're probably gonna find it corroded, and what's happening is you're getting resistance through the coil to the armature. If you clean that up really good and put it back on there, just using like some emery cloth,
Steel wool.
and put it back on there, your ground will probably go away. So kind of a tidbit there. Fan motors, 3-wire fan motors. Again, don't go take this to the bank at 37 ohms. All I'm looking for, again, is equal resistance. Whether I'm doing it from the wires, white to yellow, yellow to red, red to white, I should have equal resistance no matter how I do it. Around 40 ohms or so, that motor's not grounded, or does not have a failed winding. Then if I go from each motor lead to ground, I should have no resistance to ground. Again, if you're reading in mega, you got to ignore that. I don't think you will with the fan motor because you don't have the compressor oil, but I never say never either. And then 4-way valve resistance, again, this is rough figures. These solenoids, rough figures again, but it kind of gives you an idea of roughly what those reading should be. So the load troubleshooting on all the motors and solenoids and stuff in these units is not complicated at all. The resistance chart, when you're checking, if you actually ohm out a thermistor on the GMV products, the MultiPRO products, we still follow the same rules that the mini splits do. If it is measuring air temperature, it is a 15K thermistor. I don't care if it's on the outdoor unit or the indoor unit. If it's on a pipe, it's a 20K thermistor. So those thermistors I was talking about as far as your inlet and outlet thermistors, they're all 20K thermistors. The only exception to that rule is the 50K thermistor. That is your discharge thermistor leaving the compressor. And if you really want to get down to the nitty gritty, guys, and you got a point where you got a machine down, I don't care if it's a mini split, MultiPRO, it doesn't matter. You got a bad 50K discharge thermistor. You get a hold of the distributor. They get a hold of us. We don't have the part. Order a 50K thermistor for a mini split. It's the same thing. It'll mount to that discharge line exactly the same way. The only difference is you're going to have to cut the wires and splice it in.
Right.
But it will absolutely work.
Butt splice, right?
I recommend butt splice.
No wire nuts.
I don't like wire nuts. Not in machines that vibrate and move and stuff like that. Plus, a wire nut can allow moisture in.
Right.
Butt connector, shrink wrap around it, that's perfect.
Yep.
If you don't want to use shrink wrap, at least use a butt connector, some good electrical tape wrap around it, keep moisture out of the joint connection. Anyway, so again, those rules don't change. One other thing I will tell you and share with you, if you want to not have to unplug thermistors and you want to see if they're reading properly or not, in the GMV6 service manual, we have the voltage drops in there. So you can take your meter and DC volts with needle point probes, and you can actually take that probes right on the two wires going to that thermistor, and it gives you the voltage drop. And it also gives you the chart. At that voltage drop, it's reading this temperature.
Welcome back, everyone. Hope you enjoyed the video there and got a lot of good information out of there. We did get a few more questions that came in. We will get to those as well. One thing I remembered from the video that we didn't talk about clear enough. So the service tool, the 4-pin plug, I believe we said in the video that it will plug into the indoor units. It will plug up to the outdoor units as well, with the exception of the MultiPRO Ultra B revision. That unit is no longer in production, just so you know. But the standard MultiPRO and the GMV6 MultiPRO Ultra both have the Molex plugs on the outdoor boards that you can plug up to. So just so you know. And I believe we talked about it in the video too. It's not that some of the indoors don't have the Molex plug, but it's not always easy to get to, especially the wall mounts, because that board is installed in there just like the mini splits. It's in a little slide out, but you still got to take the whole white cover off, outer cover off, slide the board out, plug up the service tool, slide the whole thing back in, put the cover back on, and you can run the unit. So that's why I said that little adapter. I mean, there's a million different ways you can do it. I think I talked about that in the video too. But ordering those little adapters that will take you from that 4-pin to a 2-pin, two-wire connection, and allow you to plug up to D1 and D, hook up to D1 and D2 and use a portable power source. That's pretty huge. So I want to make sure I covered that. I also want to talk about some other things that have come up because it's wintertime and we've had some pretty cold temperatures, and I'm sure you all have been affected by the polar vortex in one way or another. I know here in Tennessee, where I'm from, it got way colder than it normally does down here. I mean, also, I think I sent in Pensacola, Florida. They had 9.5 inches of snow. I mean, how's that happen? So I think there's a whole lot of people who want that polar vortex to go home. But with that said, it does affect our equipment and something to be thinking about. And I'm going to have our camera guy show the sticker about the cold weather compressor warm-up rule. So we've actually did a technical tip about that, but I do want to discuss this a little bit. The best thing you guys can do when you're installing these units is to make sure you're applying power to those units. So when you're installing one of these, it's kind of backwards from any way we've ever installed one before. In other words, like when I was out in the field, the last thing you did in an install was apply power to the outdoor unit. But in today's world, it's important to actually apply that power first. So when you set the unit, apply power to it, then work on your refrigerant piping and that kind of stuff. So, but back to that sticker again then. So the sticker is clearly just telling you what to do, and you'll start seeing these on the equipment. So it's above 50, you need power applied to it for at least an hour. If it's 32 to 50, apply power to the outdoor unit for 2 hours before you start that unit up. 14 to 32, 4 hours. Below 14 degrees, we want 8-hour warm up on that machine. The standard and the new Ultra, it won't even let you start the machine because it's locked in at 8 hours. When you put that thing through commissioning or debug, it's going to stop you at step 8 if you haven't had an 8-hour warm up. That's what we're talking about here. You can override it provided we're following the rules on that sticker. As long as, like I said, if it's 32 to 50 degrees in the last 24 hours, it's not been below 32 degrees. If you've had 2 hours of warm up, you're fine. You can override it. So when it's going through compressor warm up, when it gets to step 8, it's going to stop there. It's not going to go any further. But if you hit SW3, the red buttons on the main board outside, it'll override it and let it go through the finish doing the commissioning process. If you override that when it is cold outside and you didn't give it enough warm up, think about what you're doing. That whole entire machine's got the base charge shipped in that unit. Liquid refrigerant likes to migrate to the coldest spot. And then when it's mixed in with the compressor oil, it doesn't want to leave. That's why we want to warm up that compressor. If you warm up the compressor, it's got an insulated jacket around it. It's got that crankcase heater on it. It's going to warm that compressor, cause that refrigerant to boil and get out of that oil. You want to make sure you do that before you actually start up that machine. I've had comments that, I've never had to do that before. Well, you're talking about a cold climate heat pump. Mini splits are kind of the same way. When you're running heat pumps in this kind of weather, you really need to make sure you're warming up that compressor before you initially start it. That also applies to service. Whether you've got a MultiPRO unit, whether you've got a commercial 3-phase GREE system, whether it be a heat pump or heat recovery, let's say it's got an air code on it. Maybe you've got to get a board for it. Maybe it's just a compressor drive board, but the main board's fine. Do not leave that machine powered off while you're waiting on the part. Leave the power on so that crankcase heater stays warm the entire time that thing is sitting there until you come back with the appropriate part. If you have a main board failure and the crankcase heater is not actually being energized, then you need to, when you come back, put the main board in there, you're going to have to allow the warm up to that compressor before you start that machine. You're saving yourself a lot of headache by doing that. That's why I'm telling you this, because the last thing you want to do is start that unit up and now have a bad compressor, because now the service call is definitely not over. Now we got a bad compressor to deal with. So I can't stress it enough, guys. Mini splits, same thing. If you've got a board failure and it's 14 degrees outside, don't shut off the power. If the customer tells you they have an air code, whatever the air code may be, okay, don't instruct them to turn the breaker off and leave it off until you get there. They need to leave the power on so that it is in air code when you get there and you can make sure that compressor is still warm. There's a ton of different ways you can check that. You can take the front panel off, pull the jacket back a little bit, reach your hand in there and put your hand on the compressor, see if it's warm. You can unplug the Molex plug that goes to your crankcase heater in the wiring diagram and check for voltage right there at the 2 pins where that crankcase heater plugs up. So there's enough ways you can make sure, even if you got a failed main board, you can still check it to see whether or not the crankcase heater is being energized. As long as the crankcase heater is still being energized, you're fine, even though you still got to replace that main board. Maybe there's something else wrong with the main board. Maybe it's not reading the temp sensor correctly. That's possible. You could not have the voltage out to give you the temperature sensor reading. I don't know if we talked about it in the video or not, but in the service manual for the GMV6 Ultra, you can use it on GMV standard as well. I know for a fact those tables are in there, and you can do the voltage readings for all your themistors on that outdoor unit. So it will give you a chart. If it's 10 degrees outside, you look at the chart at 10 degrees, that's the voltage reading you should read if you take your needlepoint probes and put them right across one of those two wire, one probe on each wire going to that thermistor. It gives you the voltage drop reading you should be reading to know whether or not it's accurate. So if you got no voltage at all, then the board isn't putting the voltage out to give you the voltage drop for the thermistor to be reading properly, and you're probably got an error code for thermistor failure. It thinks it's the thermistor. It could be the board. So simple checks you can do. The service tool is great for that. We plug up the service tool, it's going to give you the actual temperature reading. If it can't read the temperature, it's going to show you that. It's going to come up some weird number or no number. Okay. So I've never actually played around with that and just like unplugged one to see what it did. JD and I did a training on the mini splits where we put a rheostat on there and played around with the temp, adjusted the rheostat and adjusted the resistance. And yeah, we could make that machine fault out no problem. Right, JD?
Oh yeah. That was fun.
So, just take your time and think about what you're doing and you'll be able to get to the bottom of the problem. So with that, let's move on to some of these questions. Jesus is going to show you guys how to get to the service manual on our website.
Okay. So yeah, there we go. So we start out at greecomfort.com. We go under the resources tab and it populates, and then we go to documents and then system documentation. And then what we're going to do is we're going to scroll down to MultiPRO. Once we're at MultiPRO, we'll go to MultiPRO Ultra Heat. You'll notice it's kind of in the middle of the screen there. And so we'll go down and where it says service manual for GMVV36 WLCTU, that is the service manual that we are speaking about in this broadcast. And so it's just that one service manual for 36, 48, and 60. And like I had mentioned earlier, it has a ton of information as far as troubleshooting, what you should be reading on your control board, your compressor, all the error codes are on there. So you can, if you go to the table of contents, you'll notice that one of the selections there, where's it at? See, yeah, chapter 3 faults, error code indication. If you click on that, take you straight to the error codes. Well, some of them are status codes, so you just got to be aware.
Yeah, and that's the other thing we did with the manual. They tell you whether it's a status code, an indoor unit error code, or an outdoor unit error code. Yep.
And so I know I just pointed out a common one that we always get on the first menu there, A3. You notice defrost. No action needed. Unit is defrost operation.
That's one that we want to make sure that when you're installing these systems that you communicate that to your customer so that they understand that that's not an error code.
Right.
Unlike what I did with my own wife and didn't bother to tell her that A3 means that the unit's in defrost, and I was out of town and she's like, hey, the unit's saying A3, what do I do? And I'm like, nothing. Go back to bed.
Yeah. It's doing its thing.
So it didn't really go down like that, but it kind of did. So she was worried that something was wrong with the system. So I did, I preach to the choir sometimes and don't follow my own advice. But yeah, take the time to, explain to the customer, what status codes are versus error codes. So then another one I can think of right off the bat out of that service manual is the P0 code. You'll see that on the indoor unit. All that's telling you is you got a fault on the outdoor unit. So when you go to P0 on the indoor, you've got to go to the outdoor unit and look at that panel, and it'll tell you what the error code is on that compressor or on the outdoor unit, not compressor. It could be a compressor. So, no, thanks, Jesus, for taking us through that. Let's jump into some of these questions. Let's see. From Tyler, he says, what is the roundabout price for a service tool? Can I get the tool from my local GREE representative? Yes, you should be able to get the tool from your local GREE distributor. If they don't have them, they should be able to order you one. And the price, I don't know. So keep in mind, guys, we can't get pricing, especially in the training, when equipment is sold all over the United States. And you got different margins and all that kind of stuff. You know how it is. So it all depends on, what they can give you for price. Do you buy one thing from them a year, or do you buy $100 million worth of equipment from them? If you buy $100 million worth of equipment from them, I'm sure they'll give you one for free. It's all in how it works, right?
Right.
So we just cannot possibly give you pricing. So would the service tool be used for flex units? What do you think, JD?
No, there is not one for the flex.
So we don't currently have a service tool for the 410A flex units. There is going to be a service tool. It's in development right now. It's not out yet. That will be functional to the flex R32 unit when you start seeing those out. But the tool
That's going to plug into the board.
Yes.
Yeah.
Yeah, it plugs into the outdoor unit. I can't remember. I think it might plug up to the indoor unit too, but I know it plugs up to the outdoor unit. So, all right, another question here. Do you need power off the unit before you hook up the tool? That's a great question. What do you say, Jesus?
That is a good question. Now, I would personally say that I believe that it depends on how you're hooking up. Because if you're doing it through the Molex plug, the 4-pin plug, yeah, you just put it right in and you're good to go. Make sure that you have the other end connected to your service tool. But if you're going to go the other route where you're going to have your D1 and D2 2-pin plug, I would go ahead and shut the system down and then connect the D1 and D2, bring it back online, and then view it in that way.
Yeah, so that's a good question. And Jesus, you handled it well. The only thing I got to add to that is if you're going to use the D1 and D2 connections, if you look at the outdoor unit, it gives you a set of screws for D1 and D2 for your wiring. And then there's another set of screws for D1 and D2 wiring. So you could actually do that live because as long as you're not messing with the screws that's actually going to your D1, D2 wiring going to your indoor unit, and you're using the other screws. But if you have to loosen up the wire to be able to hook up the wire for your tool, you're going to cause a CO communication error by messing with your existing connections, right? So as long as you're not messing with your existing connections and you can hook up the D1 and D2, I would say you could do it live. But if you're messing with your existing connections, I would follow what Jesus said and power the system down. Okay. Now, as far as plugging up the 4-pin Molex plug, depends on the unit you're plugging up to. On the GMV6 MultiPRO Ultra and the standard, it's no big deal. You can have the cover off of that board. It can be powered up. You can safely plug that up. If you're trying to plug that up to an air handler, you're going to want the power off.
Yep.
Because that plug-in, that board's way up in that unit, and you're going to be reaching right past all the line voltage and everything and get your hand up in there and to get that thing plugged up. So absolutely, you want to shut the power down then. But Is it going to affect the machine plugging it up and unplugging it while the unit's powered up? No, it won't hurt the machine. What we're concerned about is your safety.
Yep.
When it comes to, that's a good, so I like the thought process there. So I'm expanding on why he's asking the question. Okay. What I think is he's wondering, is you going to get arcing and cause a problem? And could you damage the board? Could you damage the tool doing it live? That it won't. But it brings up something else to talk about. Fan motors. Don't plug and unplug those things live. You will or can very well trash that board doing that. Flexes, especially, it's got that 5-pin Molex plug. When you power that flex down, you need to wait. You either need to measure that DC bus voltage, which you can do right there on the board, and make sure it's down below 50 volts DC before you unplug that fan motor, or just wait 10 minutes. That way you know that board's had time to completely de-energize the board and get rid of the DC bus voltage. If you unplug that, if you turn the power off and unplug that right away, now you may have had a bad fan motor, but now you got a bad fan motor and a bad board. So, and that goes to any piece of equipment with MultiPRO, mini splits, any of it. Don't be plugging and unplugging loads with it powered. And when you plug and unplug, it's just like a switch making and breaking. You're going to get arcing, and that arcing can damage, especially a solid state electronic board. So be very careful. And then also, again, it comes back to safety too. You know, you don't want to be grabbing a hold of a plug that's got potential with the DC bus of being 350, closer to 400 volts DC on it.
Yep.
I don't want to be the source of one of these units discharging capacitors. That is not going to feel good. So, all right. And let's see. Will we get an email version of this training? It was great. I still need help troubleshooting a premature defrost cycle. Fan does not turn on and L3 error code shows up. System has to be reset to get it going again. So that was Mike again. Like I said, I would call our tech service department. There won't be an emailed training, but this will be posted to our YouTube channel. So you give us about a day, it should be up. So anything we're forgetting, guys?
Yeah. I just wanted to add one last thing just to kind of wrap it up. As far as the service tool goes and MultiPRO, you know, it really is something that's going to help, you know, the technicians out there in the field pretty much see what's going on with the system, you know, if they do run into errors. Because, I mean, we can't forget about, you know, our common tools that we already have, you know, refrigerant gauges, voltmeters, amp clamps, you know, the whole 9 yards. But, you know, that can only take you so far as to seeing what's going on in the actual system. You know, with service tool, you're able to see EV pulses, temperature sensor, every amperage. You're literally able to see it all on the tool, and it's just going to pinpoint you towards the way that you need to go as far as, you know, troubleshooting, getting the unit back up and running. So I just wanted to add that.
Especially refrigerant diagnostics, because being able to see that inlet and outlet temperature sensor, as I talked very much about in this video, is huge. You know, you can have the EEV open, but that doesn't mean you're actually getting flow. And these machines having those thermistors on there and using those to your advantage and using them for service is absolutely the key. And if you've got 4, 5, 6 indoor units, however many you have, even if you only have 2, being able to see that data from one location, one spot is huge. Now, if you only got 1 or 2 units, if you're using a GREE wired controller, as we showed in the video as well, you can get to that diagnostic information from the GREE controller as well. So you don't necessarily have to have the service tool. But the more you guys I hope you like the GMV6 and the GMV5 MultiPRO units, and the more you sell them, having this tool is just going to make your job so much easier. Not only for troubleshooting, but for maintenance. So if you're going out there and just doing preventative maintenance, you can plug up to that machine. You can run the entire thing from one location. So if I've got 4 indoor units, I plug in one spot, one of the indoors or outdoor, and I can run the entire thing. I can turn on one at a time. I can turn them all on. I can set them for heat. I can set them for cool. I can change my fan speed. You can do all of that from the service tool, and you don't have to go run all over the place. You don't have to go to each controller and adjust temperatures. It saves you time as well. So one thing else I did want to share, and we'll have it thrown up on the screen here, is the service tool part numbers for the service tools we have now. We do have a single zone mini split service tool. As you can see with the part numbers up there, we have a multi-zone service tool for multi-zone mini splits, and then we have the MultiPRO service tool. So keep in mind, the mini split world of communication is different than MultiPRO. MultiPRO uses CAN bus. Mini splits use that 4-wire connection, and your 2-wire is your communication. It is not using CAN bus. That's why the service tools, part of the reason why the service tools are not interchangeable from one piece of equipment to another. The Flex is a 24-volt driven machine. The new R32 Flex, you're going to be able to have it 24-volt driven or using a GREE controller using RS-485. That's why they're able to give us a service tool that will work using RS-485 to give you a service tool. Okay, so things get better as we go along, right? Like anything else. If I had to choose tools, let's say I sold and installed GREE mini splits and MultiPRO, I would get the single zone service tool, but you can use that on a multi-zone system. You hook it right into your 1, 2, 3 wire connections, and you can use it for, getting the data off the machine. Just keep in mind, you're only going to see the indoor unit for the circuit you're connected to. So if you're connected to a circuit, you will see all the outdoor unit information, and you will see the indoor unit information on the A circuit only. If you move it to B, then you'll see all the outdoor unit information, and you will see the B circuit indoor information only. That tool can also be used to simulate an outdoor unit, to test an indoor unit, and it can also be used to simulate an outdoor unit. Simulate an indoor unit to test the outdoor unit. So very versatile tool. We didn't cover that in MultiPRO Service Tool, but just so you know, that MultiPRO Service Tool also has simulation to it too. You can hook that up to a indoor unit that is not connected to an outdoor unit and simulate an outdoor unit and power up an indoor unit to see if there's anything wrong with the indoor unit. So that service tool has I can't tell you how much the MultiPRO, I forget all of what the MultiPRO Service Tool will do. So, but if you do buy one of those, like I said in the video, first thing you want to do, as soon as you get it, don't even hook it up to a system. Just hook it up to I would glue the port first just to secure it. And then just use your micro USB adapter to USB and plug that thing up, power it up, and you just sit at your desk. And I would set it for bridge, like I was saying, so you don't have all the metric measurements, and then just get familiar with the tool. That way, when you get out to the job, it's just that much easier to use it. So, looks like there's the tool mentioned about updating programs on the tool and or mini splits. What are they referring to about updating? So as far as updating programs on machines, that's more when it's directed by the factory and an update needs to be done to the machine. So there's nothing you're going to be doing updates to it without direction from the factory.
Yeah.
Anything else that you guys can think of that we forgot to cover?
No, I think that's it.
Awesome.
I'm a fan.
I thought it was a good broadcast. I think we gave a wealth of information out there, a lot to digest. Like I said earlier, it will be rebroadcasted and available on our YouTube channel. So if you need to go back and re-review or want to look at something again in the training, once it's posted, I like that myself because you can actually stop and start it wherever you want, maybe take notes or whatever. So, but this will be getting posted to our YouTube channel. So, well, there's no more questions, so I think we're going to wrap it up. And as always, remember, at GREE, we're by your side.